Good day, everyone, and welcome to Physics and Mathematics lovers. In today's tutorial, we shall learn the topic on mathematics, logarithm. But before we do that, I want to sincerely apologize to everyone out there for keeping you waiting for this video lesson. I want to say that I'm very sorry because due to my extracurricular engagement, and as we do so today, God will bless you. I want you to share this video as you watch, extend this knowledge, and also like and comment. As you do so, God will bless you. Today, we want to learn the topic, logarithm. When we say logarithm of number, for example, to a particular base, it means the exponent or index to which that particular base must be raised to give you the number. Look at it now. If I say log, look at the logarithm form. Log x to the base a is equal to y. This is what a logarithm function. What we are actually talking about here is that if I say log s to base a equal to what? Y, it means this particular number here, a, this is the base. It means this will have to be raised. It has to be raised to this. And here, it will become a raised to power y equal to what? X. Here, this is the base. And this is the exponent we are talking about. So now, when we talk about log of numbers, it then means that the exponent to which this particular base must be raised to give you what? X. So that is what just happened here. We have what? A raised to power y equal to what? X. So this here, this particular value here, which is this exponent, is the what? Solution to this what? Logarithm. Log x to base a. So that is why I have here index form. So for you to understand logarithm, you must understand what indices. So it is the indices, the knowledge you gain from there that will help you to what? To evaluate logarithm. So now, if I say, for example, I say log 1000 to base 10. What is the value of this log 1000 to base 10? So it means what value must this 10 be raised to give me 1000? That is what this logarithm is talking about. So if I want to solve this, I would say let it be equal to what? X or any number. So according to the law of logarithm, it means that this 10 has to raise to this, which means you give out 10 raised to power x equal to what? 1000. As you can see, it has become what? Index form. So from logarithm, you transfer to what? Index. So from index, you can also go back to what? Logarithm by taking the log of what? Both sides. Now look at it now. I want to get solution to this question. What I will do, I will have to express this one to what? To the powers of what? 10. Which means 10 raised to power s is equal to 10 raised to power 3. So according to exponential equation, when I have same base, so this one will have to go. So x will give me equal to what? 3. So which means log 1000 to base 10 is equal to what? 3. So that is what logarithm is talking about. Now we have two types of logarithm. When I talk about logarithm of numbers, we have what? Two types of logarithm. The first one is what? Common logarithm. The common logarithm is those ones that are expressed in base 10, just like what I just solved. If I say log 8 to base 10, so this is a common logarithm. Or simply write it like this, just say log 8 without what? Denoting any base. So when you see a number written like this as what? Log 8 without writing any base, it means what? It is in base 10. So we still have the second logarithm, which is called what? Natural what? Logarithm. Natural what? Logarithm or natural log. So the natural log are those logarithms that are expressed in base e. For example, if I have log x to base e, or any number like this, log, let me say 10 to base e, rather. So we have log 10 to base what? E. So this one can be obtained from what? Tables. That is why when you see four-figure table, you see natural logarithm. We also see what? Common logarithm. So this is how far we can go for introduction. What I wanted to understand, there is a relationship between log and indices. This is your index form. So from index, you can move back to what? Logarithm. So it means that when this number is raised here, the exponent, it is what will give us x. That is what? In logarithm form. That is why I have what? Log x to base A equal to what? Y. So this we have to raise to this to give you equal to what? S. That is what happened here. So we have to what? Be what? A raised to power Y to give you what? X. So this Y here is the exponent, and this one is the base. This is the log. God bless you. Do not forget to share this video. As you are watching, try to share, comment, and also subscribe to our YouTube channel. God bless you as you do so. Look at basic laws of logarithm. Number one law that we have there is product or addition law. When we talk about product or addition, we're actually referring to that particular law that combines the expressions of what? Logarithm. Now look at it here. If I have log x, we have two different numbers there, x and y. Now they have what? A common base, which is what? A. Log s to what? Base A plus log y to what? To the base of what? A. So the law says that what? I am going to what? Multiply x and y together, then I take their what? Common base. But you must understand that this base here must not be negative. It must not be negative, and secondly, it must be greater than 0. Thirdly, it must be what? Not be equal to what? 1. So that is the law of addition or product. Now let's evaluate this with this example. The first law. What this simply means, they ask us, now look at the question here. It says simplify log 3 to base 4 plus log 6 to base 4. Now what they want us to do, just simply say, according to the law, just take 3 and 6 representing x and y, which means I am going to have log 3 times what? 6 to the base of what? 4, which is what? 4. So at the end of the day, 3 times 6 gives us what? 18 to what? To base 4. So this is your final answer. If you are asked to find the solution to this logarithm, that is when you what? You express further. Now they just ask us to simplify. Simplify means what? Reduce it to the lowest term. So this is what this first law is talking about. That's how you can apply that. Now let's move to what? Second law. It's called what? Quotient or subtraction law. Yes, the quotient there means that at the end of the day we are going to divide. Now the subtraction law there is because of this subtraction that is between the two what? Numbers. Log x to base A and what? Minus what? Log y to base A. At the end of the day, we are going to divide this first one here by this what? Y, which is what? Like this. It will become what? Log x over y to the base A. That is what? The common base. And remember, the base must not be equal to 0. It must not be equal to 1. And secondly, it must not be what? Negative. It must be greater than 1. Let's simplify this example according to that law. Look at it here. This represents our x, while this one represents our y. And this base here, 3, represents what? That A. At the end of the day, I'm going to have what? Equal to what? Log 40 all over what? 10 to base 3. So at the end of the day, it will give me equal to what? 40 divided by 10. It gives equal to what? Log 4 to base what? 3. This is what they just want us to do. So this one, it just was simplify. You were not asked to find solution. So if we are asked to find solution to this, we will go further in our next video. Thank you so much. God bless you. This is the first 2 laws of logarithm. I will be bringing the next laws from our next video. Do not forget to share this video and also comment. God bless you. Or power rule. Yes. And when we have log of a number like this, x raised to the power n, that means the log of this number raised to power n to the base of a, which is like this. Then, according to the law, it says that this n, we have to multiply the log of x to base a. That is what the law says. So, log s raised to power n to the base of a. It will be equal to, take this power, come and use it to multiply what? The log. That is what we have here. Now let's look at this example here to show it. Assuming we have what? A single logarithm like this. So why I'm using this now to illustrate this, By the time you have what? Combination of this law and the other ones that we have studied before in our previous video, so you begin to apply each and every one of them. So let's look at this now. If I have log 1 all over 64 to base 4, so at the end of the day, I am going to express this 64 to the base. Let it be what? To the powers of what? 4. So at the end of the day, it will become like this: log 1 all over. Do you remember that in our indices, 64 can be expressed as what? 4 times 4 times 4, which will now give us equal to what? 4 raised to the power of what? 3. 4 times 4 is what? 16. 16 times 4 is what? 64. So I will put what? 4 raised to power what? 3. Then to base what? 4. What I will do in our indices, if I have 1 all over what? X raised to power n, it will give me equal to what? X raised to power minus n. So apply this to this place. It will give us now to be equal to what? Log 4 raised to power minus 3. Then to base what? 4. Now you can come and what? Remember this our law that says that what? I will use this exponent here to this exponent of this number to multiply the log of what? This, which will now give me equal to what? Minus 3 log 4 to base 4. Now, there is one law of logarithm that I have not told us. When I have log a to base a, that means when I have log of a number to that same number, to the base of that same number, it will give us equal to what? 1. So, which means the whole of this number here, the whole of this place, the entire this place become what? 1. So here, in this case, we apply it to this one. So it will now give us equal to minus 3. Then the whole of this place now, since we have a log 4 to base 4, so it will give us what? 1, which means I am multiplying 3 by 1. So the final answer becomes what? Minus what? 3. That is the answer to this what? Question. As you that have watched this video, please do not forget to share this video to extend this knowledge, and also subscribe to our YouTube channel, Physics and Mathematics Lovers. God bless you. Application of logarithms. But before we do justice to this question on the board, please do not forget to share this video. Please share this video and extend this knowledge. Also subscribe to our YouTube channel, Physics and Mathematics Lovers. Look at the question on the board. It says log 50 to base 10 minus log 5 to base 10 plus log 100 to base 10. Yes, this is a combination of both addition and what? Subtraction law. So what we do, according to the laws of logarithm, we first of all make sure that what? We write what? Solution. Now look at what is happening here. Let's rearrange. This log 50 to base 10 here is positive. Collect the like terms. Look at this other log here. This one is also positive here. So we move this one together. You write log 50 to base 10 plus log 100 to base 10 minus log 5 to base 10. You remember our addition law. It says that what? When I have positive and what? We have the log of different numbers and of the same what? Base. They are of the same what? Basis. What we do, we take what? The two numbers, we multiply them together, then we take the common base. So that will now apply to this one also. This one is what? Subtraction. Subtraction says that we are going to divide whatever log, for example, this and this. What we are going to do first of all, we follow what? Order of what? Operation. The first order of operation is what? Addition. We first of all deal with addition here. We are going to have what? Log. To become 50 times 100. 50 times 100. Then because of this minus that is here, this one now we have now combined this now to what? 1 log. So we now have to combine this one with this now. Because of this minus, I am going to divide this one by what? 5. So, which means I will have a common base what? 10. So multiply 50 times what? 100. Give me what? Log 5,000 all over what? 5 to base what? 10. So now you can what? Cancel out. This is log 5,000 rather. This is 5,000. So when you cancel out, we're going to have equal to log 1,000 all over what? 10. So this is what we have obtained now. You have combined the whole of this log now to this. So we are going to evaluate this now to get the answer. Remember we said that what log means what value must this 10 be raised to get our 1,000. So we are going to say let's log 1,000 to base 10 equal to what? X. So according to that law, according to log in general, it means that I have to raise this one to this, which means 10 raised over s equal to what? 1,000. So we have changed this one to what? Exponential what? Function. What we are going to do now, also what? Express this one into powers of 10. What does that mean? How many 10s do we have inside here? So 1,000 is taken as what? 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is what? 1,000. So I am going to write what? 10 raised to power s equal to what? 10 raised to power 3. So at the end of the day, 10 will cancel 10. My s is equal to what? 3. So the whole of this logarithm you have just expressed, it gave you what? 3. So this is your answer. So when you evaluate everyone, so this is your final answer. God bless you. You that have watched this video, why don't you just share this knowledge to extend knowledge to people? And also do not forget to subscribe to our YouTube channel, Physics and Mathematics Lovers. God bless you. Substitution in logarithm. And we'll talk about substitution in logarithm. Simply means that when you are going to replace that particular value of that log without using your table, just use it to replace it. Now look at the question. Given that log 2 is equal to 0.3010, then we have log 7 equal to 0.451. Now listen, what I want you to understand. When you are giving log like this without putting base, it means what? It's a common logarithm, which means it's having what? Base 10. Now let's go. Let's write solution. We are going to evaluate log 112 plus log 8. What we are going to do, if you notice now, we have log 112, and what we are giving here is what? Log 2 and what? Log 7. We are going to make sure that we break all this log into what? 2 or 7. So that at the end of the day, we are going to use these values that are here to replace them. What are we going to do now? In my what? 117, 112 rather, 112 is sitting as equal to what? 16 times 7. 16 times what? 7. So which means 16 times 7. Here I am going to have what? Log 16 times 7 as 112 plus here I am going to write log 8. Now let us apply addition law. Remember, in our laws of logarithm, it is addition that gave us this. It is addition that will give you multiplication of the two log. So let us reverse it back to addition. So which means log 16 plus log 7 plus log 8. Now you can see at the end of the day, we are having log 16 and what? Log 8. This 16 can also be broken further into what? Remember that 16 is equal to 2 raised to power what? 4. Which means 2 times 2 times 2 times 2. It will give us what? 16. So I am going to write log 2 raised to power 4 plus log 7. Also break log 8 into what? Powers of 2. In our log 8, we are going to have a log 2 raised to power 3. So you can see all of them have been broken down. Now you are going to apply the power law that says that if I have log x raised to power n to any base, I am going to, let me say base a, and I'm going to multiply it like this. It will become equal to what? N log s to base a. So at the end of the day, we apply this now. Here will become what? 4 log 2 plus log 7 plus 3 log 2. See that now? So at the end of the day, you are going to also collect the like terms. Look at it here. I have 4 log 2. I have what? 3 log 2. So I am going to add these two together. I'm going to have what? 4 log 2 plus 3 log 2, which is plus log 7. Now, this and this, they are the same. Add them. I don't know. I'm going to have what? 7 log 2 plus log 7. So recall that your log 2 is equal to 0.3010. So replace this one, put this value here. I'm going to have what? 7 brackets 0.3010, then plus, what is our log 7? Look at our log 7 here. It's what to what? 0.8451. So now let us multiply. When you multiply now, let's multiply. Times 0, here will give us 0 times what? This is 7, 0, this is what? 2.1. So at the end of the day, that is what? 21. So we'll give you 2.1, this plus 0.8451. So let us add. So when you add, then you have 1, 2, then we have what? Okay, 1 plus this one give us 1. This 2 carry 1 plus this 1 plus this, that is 5. Then 8 plus 1 gives you 9. So we have what? 2.952. This is your final answer to this question on the board. So as you have watched this video, please do not forget to share this video. Also like, comment. If you have any question, write it on the comment section. God bless you. Bye.